and how styles are experienced by whom. And we're also going to take a moment to challenge whether the popular notion of programming style really is analogous to how style functions in other domains of creative expression. And our critique is going to result in this claim that the underlying paradigm disguised by this notion of style is that programs consist of imprisoned expressions. And we're going to describe what we mean by that and contrast it to our notion of open authorship. And finally, since we say that expressions are imprisoned, we're going to consider how we might free them from their prisons. And we're going to illustrate this through a small demo programming language that we developed in Python. And then we're going to ruthlessly critique that demo language and argue that it falls far short of our more ambitious goals and talk about what that implies for our research. Before all that, though, I would just very briefly like to note something about the style of this presentation and of the paper written. So I'm very thankful for one of our reviewers who pointed out that our paper is written using a running metaphor of a prison, and that is something that can have some kind of ugly connotations if it's considered to be flippant, because prisons are sites of institutional violence, and programming is entangled with institutional violence, but that's not what this paper is about. And we have chosen to present this paper much as we wrote it, keeping all of that there, but I would just like to note that is not something that I'm necessarily entirely comfortable with. But moving on, what do we mean when we talk about programming style? One early canonical text explaining what style is in programming is by Kernighan and Plauger, and it is the elements of programming style, which is, of course, a kind of a pastiche of Strunk and White's The Elements of Style. This book is presented as a series of editing exercises where Kernighan and Plauger start with code samples from programming textbooks of the time, and then they transform those to make them more stylish. And in their view, style is about communicative clarity. It's about the ways that a program is written not just for a compiler, but for human readers. So specifically how it serves programmers who need to understand the functioning of the program, to explain it, or to maintain it. And therefore, they focus on what could be called surface details of programs, such as the use of indirection, repetitions in the program, the use of comments, and so on. This is not what we focus on, however. We are using a different later book by the programming educator and programming language researcher, Cristina Lopez, called Exercises in Programming Style. So this book is a compendium of 33 reworkings of programs that solve the same task. This task is a kind of a simple word frequency counter that receives a text and tells you how many times different words occur in an ordered list. And the book additionally contains reflections explaining these styles and their purposes, and exercises where readers reflect themselves and extend those programs. There are additional examples of these styles that are continuously being added to this GitHub repository that is partnered with the book linked below. So in Lopez's book, style is considered as a way of expressing a computational task. It is a choice you make that introduces certain trade-offs. And as opposed to Kernighan and Plauger, Lopez is focusing on styles as being about how computation is organized. So, for example, there's a sample that it solves the problem as it would be implemented on a stack machine. There is one using data flow programming, one representing inversion of control, and so on. So even though all of these samples in the book are implemented in Python, many of them actually emulate different paradigms that we associate with particular programming languages, such as Haskell and C. And in fact, Lopez argues that there is a sort of a continuum between stylistic choices that are embedded in programming languages and ones that we make within one language. So this is one example of a solution presented in the book. This is style number 9, called the one, which is in reference to the fact that this is a solution to the word frequency problem that is solved analogously to how one would do it with an identity monad in Haskell. And from the outside, when the program is actually executed, here using the full text of Pride and Prejudice as the input, this is how the result should look. And this is in fact how the result should look for every program, because the exercise is defined as such, that whichever style you use, this should be the eventual output. So why is it that we have focused on this book in particular? Lopez's book is a kind of a travelogue or a compressed history of programming. It does a really great job of actually reflecting the trade-offs and value judgments that real programmers discuss when they design their programs. I liken the discussions in the book to a really good Stack Overflow answer, where the respondent takes the time to not just present a solution to you, but to actually talk about the context in which that solution makes sense, and what it is that you get out of doing things this way rather than a different way. And because of that, this book helps us look at the differences between styles, but also what remains the same across styles. And what remains the same for us is a kind of a problem to do with what styles are and what programs are. So in the book, there is a seemingly great diversity between all these solutions to the problem, but there is also a shared qualities that we consider negative. And these qualities can be boiled down to two aspects. One is that the code, the choices about what computation happens and how it's organized, is imprisoned within the source code. Once the program is running, there is no longer any connection between the stylistic choices made in the code and the actual artifact that you're interacting with, whether as a further programmer who is a client of the program or as an end user. And this is related to the fact that these styles are inward facing in the sense that they address the experiences and the values of the community of programmers, specifically the programmers who have direct access to and authority to edit the source code. So these styles are not really styles for any consumers of the program. And this is really not surprising, considering that the definition of the exercise is, of course, that every program should be experienced identically. So when we say that expressions are imprisoned, what do we mean? What is the layout of this prison? Well, we consider it to be somewhat really similar to this illustration, which is an illustration of hell as presented in Dante's Divine Comedy. So in this prison, there is no single point of oversight. There's not a guard tower that can look down upon all the prisoners at once and see their movements and control them from the top down. Instead, the prison is a series of staggered layers which totally contain and obscure each other. So we could see this this layered structure sort of analogously reflected in how on one end we have the people who design the hardware and make all the choices about computational organization there, and that they then pass the baton on to higher and higher levels of the technology stack, ultimately ending up in the so-called end users. And this really is very reflective and embodying of the canonical virtues of programming, where we practice information hiding, and we have insulating abstractions, which mean that there is a very limited surface of communication between one layer of computation and the next. Another image that might describe this analogy we're making quite well is this one, which was found on Jonathan Edwards' blog. They're called separation of concerns. So we are arguing that imprisoned expressions are bad because they run counter to the values of conviviality. Ivan Illich said in his book, Tools for Conviviality, that convivial technologies are those that can be easily used by anybody as often or as seldom as desired for the accomplishment of a purpose chosen by the user. And by contrast to this, when expressions are insulated within their abstractions and in use are completely hidden from any consumer of the program, what happens is that the original programmers, that is the people who create the architecture and the framework and the source code of a given solution, have a lot of say over what is desirable functionality. And the people who are further consumers of the program or subsequent authors have very little to do to change the functionality and the parameters of computation. So how does this book actually reflect what styles are? Lopez, much like Kernighan and Plauger, is inspired by a different text. Exercises in Programming Style introduces itself as a kind of analogy of the book Exercises in Style by the French writer Raymond Queneau, and I probably butchered that name. So in referencing Queneau's work, Lopez says that style was nothing but the consequence of writing under constraints. By honoring different constraints, we can write a variety of programs that are virtually identical in terms of what they do, but that are radically different in terms of how they do it. Now, we're arguing that this is not a complete notion of style, or at least it is one that we are dissatisfied with. And to talk about what a different notion of style is, we are going to take a short diversion into a different history of analogies in computer science. So we've seen this kind of borrowing from other disciplines before. Christopher Alexander and other architects developed this notion of pattern languages that underlie the design of good architecture. And this was drawn into the programming community by Gamma and colleagues, and resulted in the design pattern community, where we can catalog and taxonomize different solutions to a problem in a context. And Alexander really had mixed feelings about this borrowing. There's a great keynote that he actually gave to the 1996 UPSA conference, where one of the more critical bits is him saying, "My comment on this," by which he means the way that programmers approach design patterns. "Please forgive me. I'm going to be very direct and blunt for a horrible second. It could be thought that the technical way in which you currently look at programming is almost as if you were willing to be guns for hire. In other words, you are the technicians. You know how to make the programs work. Tell us what to do, Daddy, and we'll do it. That is the worm in the apple." So what is it that Alexander is saying here? How are programming design patterns different from the way that he and his community use design patterns in architecture? Here's an example of one of Alexander's design patterns, this one for the 6-foot balcony. It says, "A balcony is first used properly when there's enough room for 2 or 3 people to sit in a small group with room to stretch their legs and room for a small table where they can set down their glasses, cups, and the newspaper. No balcony works if it is so narrow that people have to sit in a row facing outward. The critical size is hard to determine, but it is at least 6 feet. So what's going on here? Alexander is referencing a living context of use, people who have their own ideas of what the balcony is for, which might change over time. And also a design context where the pattern has to be carefully evaluated for how it fits into the particular building and the particular users that it will have. It is also part of a larger conversation about design. This pattern, in fact, in its extended form, references other patterns and talks about how they might come to interact with one another. And as Alexander emphasizes in this keynote that I referenced before, there are moral values embedded in this pattern about what use of buildings look like, what consists a good building, that are not just about the values for those who construct a building, but for those who use it. So this leads us to think of styles in a different way from Kernighan and Plauger, and a different way from Lopez. We could speak of styles as being about how programs create a relationship between programmers and between users. So rather than just looking inward toward the experiences of those who write the program, styles should look outward to the context of use and reuse. And in this way, styles should account for how particular programmers and the community of programmers is put into correspondence and interacts with particular users and readers and their communities. So more concretely, we believe that styles should account for how programs that are made in a particular style participate in an open ecology of programs. And to define further what that means, I'm going to pass it off to my esteemed colleague and co-author, Antranig.
Thanks very much, Philip. Let me just try to share my screen. Yes. Here we go. Has this worked?
It has.
Yep.
Great. So, thanks, Philip. And so, as a lightning recap, we've surveyed what is a seeming diversity of ways of expressing computation, but rather than expressing an open ecology allowing for open conversations, putting authors in correspondence with their audiences, we instead find that these styles delineate the boundary of a prison. So how could we get out of this prison? So I'll skip to the punchline immediately. We're not going to get out today, because what we're going to produce is yet another Python program that lies soundly within the convex hull of the design space surveyed by Lopez, but we're going to argue that we've journeyed as directly as we could towards the part of the prison in which there seems to be more light in the direction of openness and what we will develop as a notion of external composability. So we've already had some interesting talks in this week about the notion of a program composition, and we want to emphasize that the kind of composition we're looking for here is different in at least two important ways. So program composition goes back a long way in the literature. As conceived by writers such as Backus, the ability to compose programs is only granted to technicians who are privileged by access to the source code of the program. And as we saw in talks earlier this week, source code is not an adequate design blueprint for a program. It's not even perhaps a meta blueprint for a program. We're looking for ways to compose programs as they stand. So without the ability to compose programs in the wild, as they are found executing, we can't have any ecology of building. So whilst Alexander's language was ostensibly aimed at architecture professionals, without this possibility of what you could call visible or external composition, the ecology of design conversations isn't sustainable. So we can refer to Stuart Brand, who talked about a more democratic notion of design ecology in his How Buildings Learn, especially in chapter 3, which he calls the low road, about how people appropriate and take on board buildings designed by others. So this kind of building is the bricks and mortar of our profession. Without proper materials to underlie our activities, we can have no community and we can have no styles. So there are clues in amongst Lopez's taxonomy. Some of the styles mention the ability to use the solution to one problem to build solutions to a related one without modifying them. So in Lopez's exercise 14.2, she comes up with a variant challenge in which you don't just print the top 25 words by frequency, you only print out the ones that contain the letter Z. And she places some constraints on the composition task, which are in practice pretty mild. And so we're going to see how we can tighten up these constraints in our mini composition system. So reuse, I mean, all of these terms, all of these sort of strange debased terms that we kick around, reuse has been a bugbear of programming system design for decades, and there are so many programming language developments that purportedly support it. And as Philip answered in remarked in his critique earlier in the week, most of these approaches to reuse actually positively defeat reuse as actually practiced. So genuine externalized reuse must be enacted by what we will call a purely mechanical operator, which we'll denote by this operator circle plus, but we're noticing that this is not a formal operator of the kind that type theorists and others like to sling around. It doesn't operate on algebras or types or other kinds of meta design elements. Once we have delivered a proper composition operator, it will actually compose programs as they stand. Ordinary citizens could use this device to compose programs amongst themselves. I will appeal to a certain superhero who is a favorite of my son's at the moment, the superhero PLUSMAN, who doesn't just merely algebraically compose things. He does whatever is necessary in the world in order to cause things to compose, and you see things drawing together, and you see the composition process happening under your eyes. And so this should be distinguished from merely connecting two programs. This was an interesting observation following Marcel's talk. So anyone can compose programs at their edges. What we're talking about here is composing programs across their entire design surface and appealing to a notion that our colleague Clayton Lewis is fond of citing from Jared Lanier. This often goes by the name of phenotropic composition. And our notion of insulation between expressions restricts the kinds of composition that we're willing to contemplate. If we buy into metaphors such as Alan Kay's biological metaphor, the idea that you would compose a program anywhere other than at its edges is inconceivable, because the edges of the program is where it communicates with the outside world, and we see this.
Just a note, Antranig. PLUSMAN has about 3 to 5 minutes left.
Very good.
Sorry, thanks. There is no nice way of doing that in Zoom, apparently.
Nope, that's well appreciated. Where was I? Yes, pushing things to the edges. And as we see in the favorite notion of functional programmers, who always exclaim that they are not about banishing side effects, they are all about pushing the expression of side effects to the edges of programs. And we ask, where is the edge of a program, and why should it only be possible to add things together at the points which were designated by the original privileged designers? So we will design our configuration system in a way which might appear somewhat retrograde. Rather than designing the semantics of our system first, we will design the mechanism of composition first, and then design the semantics afterwards. So our configuration language is designed to be composable by simply the superposition of the hierarchical structures which designate the design. So if these were JSON representations of programs, you would compose the two programs by simply superimposing them by the deep extend operator that's familiar to many users of, for example, JavaScript frameworks. So in the words with Z problem, Lopez's exercises explicitly exclude the requirement to deal with program addition at what you could call the heart of darkness of the program, the point where the overall design is assembled in a functional pipeline of the kind you see here. This is a forward functional pipeline, whereas in the snippet we saw earlier, this was expressed backwards. But regardless of which way round you write this pipeline, it represents a central point where composability fails. All kinds of things are coupled together here, data flow and sequencing, and there are all kinds of what you could call excess intention expressed here. So our miniature configuration language we call weak T in a nod to our long-running experiment with designing configuration languages named Infusion. This is implemented in 50 lines of Python, which turns out to be at least as complex to implement as the original word count task. And we show the site of the implementation of the program addition operator, where we simply superimpose the structures that designate the programs. So here's a section of the configuration for the base program, which solves the original word count issue. So you can see that the design has been given this feature we call alignment. The design elements have been given names which give them coordinates, that is a named site where they act, and which they can make references with reference to these symbolic arguments. But you can see this is extremely verbose, and we just have a small section of the design expressed here. But here we have the complete differential design. That is, this is the complete configuration for expressing the additional expression, indicating that we interpose, we intercede in the original design to implement the subversion of its data flow to enact the words with Z task without altering it. So in practice, we've failed to get out, as we already revealed ahead of time. Whilst we can enact the program addition operator outside the runtime, that is, we don't need to make use of the privileged facilities of the runtime and the compiler, we can't actually feed the results of the operator back into the system. Significant amounts of the program are still written in Python code, in particular the parts that actually perform the computation, and we've significantly increased the verbosity and cognitive overhead of the program in a way quite similar to the way reported by Marcel in his storage combinators paper, which I think is a sign that both of us must be on the right track. So it was a summary of the kinds of things we will need to get out. We will need sophisticated visual and non-visual tools that make it easy to flip back and forwards between different representations of the same design. A way to quietly assign plausible names to parts of the design that the author weren't inclined to do. So we saw, a failure for this in the talk earlier, where a meaningless name was assigned to a newly instantiated design element. So guessing plausible names is a hard task. But most importantly of all, we need an alternative execution model. Rather than reducing expressions to values, programs must expand to traces. So see Jonathan Edwards's subtext designs for more examples of how such things are done. But you see, what we failed to do in our program is to actually account for the executions themselves. We failed to have what Stephen Kell would call first-class executions. So we've only externalized the outer shell of the program design. And then, of course, the final step, export such configuration from all structures in the operating system, enriching the existing meager metadata accompanying programs as they're running in memory and sitting on disk. And for example, as you can see, Stephen Kell's cake and pie integration language systems. So I've run to the end of this talk, and it's now time to turn over to our well-beloved colleague, Colin Clark, for the critique.
Thanks, Antranig. That was great. I will attempt to share my screen. I think you have to stop.
Actually, yield.
Yield it.
No, I've not yielded the right thing. I yield.
All right. Share screen, PowerPoint. And can you see my slides? Great. I'm gonna do the impossible of try to cover 32 slides in less than 15 minutes. Wish me luck. My goal is to go back to the texts of each of the things we've heard Philip and Antranig talk about, including the text of their paper. And I was really impressed to see how the thinking has evolved from the writing of the paper to this presentation today. And what I'm interested in is this question of what actually is style in some of these texts we've been hearing about. So Philip and Antranig mentioned the classic Strunk and White, basically a set of guidelines and rules for writing style. They say things like omit needless words, beautiful, compact, and certainly applicable in many different contexts and cases. Kernighan and Plauger draw from directly that catalog of rules idea of what style might be, and their rules might say things like use variable names that mean something. Lopez, as Philip pointed out, it looks at style in a slightly different way, and she's drawing on Quinault and the Oulipo approach to writing, which I'll elaborate a little bit more on in a second. She says programming style is what results from writing programs under a set of constraints. Now, Basman and Tchernavskij, in their paper, Escaping the Prison of Style, seem to say very little about what style is. There's no definition, there's no venture in terms of what style might be in the context of their critique. What I see underneath some of these ideas of style increasingly is the idea of a kind of culture industry of style. And we can't underestimate the way that Hollywood, that capitalism and consumerism, this industrial model of how artworks and creative practices are produced, has shaped the way we think about things like style. So I borrow a slide from a presentation Krista Lopez gave about styles and her book, Exercises in Programming Style, in which she juxtaposes all of these different artistic styles together side by side. And one could read this as, in fact, the idea that perhaps styles are in some way exchangeable. They're all about art. They may be different, they may have different pros and cons, but ultimately styles are styles. We see the further articulation of this kind of idea of style as an interchangeable, exchangeable commodity through and there are many of these kinds of sites. This is an example of deepart.io, in which you can upload any photograph that you've taken, choose amongst a palette of predefined historical artistic styles, submit it to the server, and you will receive back your photograph applied in the artistic style of your choice, such as Van Gogh in this case. So again, style becomes something you simply apply onto existing content or material. So I want to look at, Lopez's book is quite fascinating for the fact that it's so inspired by what is ultimately a very weird and wonderful piece of experimental art in Raymond Quinault's book. She describes the book as a masterpiece of writing technique in the way that it illustrates many different ways that a story can be told. And that she says the book shines the spotlight on form rather than on content. And the thing about the Quinault book to know is that it's 99 variations on ostensibly the same story applied through many, many different techniques. If you trace back what Quinault himself was thinking about when he wrote this book, he was thinking about Bach, and in particular, Bach's Art of Fugue, which he described as variations proliferated almost to infinity. So you don't hear Quinault saying that he was writing a book of pedagogy or a book of style in the sense of Strunk and White or Kernighan and Plauger or Lopez herself, but rather he was, working through the incredible proliferation of variation that he could think through. So my argument is actually that through the lens of computation and programming's reduction of the definition of style, we're misreading Quinault and then narrowing our whole concept of style in this discussion. So I'd argue that Quinault's book is actually a work of art in which form's explicit foregrounding embodies a critique of the form-content dichotomy. So the fact that Quinault promotes form to actually becoming the content, the subject of his book, means that we have to start to question whether form and content are indeed as distinct as we might think. More importantly, I think it's a work of reference and relation, which we have to understand as having been created in the experimental artistic context of 60s France and deeply connected with communities of collaborating artists. So Oulipo, which was the community in which Quinault worked in, also referencing Dada, Fluxus, other things that were happening in the 60s around this challenge between the form and content dichotomy. Again, this book that's the inspiration for exercises in programming style is not simply a pedagogical text or a catalog of forms. So we start to see through looking at how Lopez talks about style, this increasing technologicalization of style. So she says, independent of their origin, and programs are virtually identical. It's just the style that changes. So I argue that here style has been conceptualized as a purely technical quality, like so much in computation, and we see this repeatedly in our discussions around programming. Style has become instrumentalized here. And we lose something. There's something here that once we instrumentalize style as simply technique, we lose some essential qualities that I think are also missing both in Lopez's book and in Basman and Tchernavskij's paper, and in how we approach programming in general. So this instrumentalization fails to recognize two essential qualities of style in my mind. And the first is that stylistic form is entangled with content. And the second is that styles have histories and places. A quote from Gilles Deleuze talking about Leibniz and monads, I think in a very different way than a programmer might talk about monads. He says, the expression expresses something, but this something does not exist without its expression. And this is very important in terms of understanding the idea that a style can't simply be placed into the context of some predetermined content and imagine that that content somehow prevails despite the style. Style expresses in some basic way the content that ends up being received. So yesterday, Marcel mentioned that I think something to the effect that paradigms are what we don't think about. And I think that's exactly right. What we do often think about is the ideas of abstraction, generalization, higher order, and universal. These are the ideology of computation that cover over the much more complex histories and contexts of the subjects we're working with. So basically, my critique here is that to think without history and without place is to do a kind of violence. So to bring back this idea of drawing inspiration from artistic form, I want to refer to the quilt work of Gee's Bend in Alabama. And there's this wonderful book that's been written about all the quilts made in Gee's Bend that really draws some interesting questions. One could certainly think of these quilts as being stylistic. They have consistent techniques, material constraints that each of the artists applied when they were making their quilts. They're beautiful works. You know, obviously a community of practice that was very concerned with certain kinds of techniques and certain materials in this technical sense of style. And yet we can't possibly understand the quilt work of Gee's Bend without understanding the people who made the quilts and the places they live. Were we to abstract the style of Gee's Bend quilting outside of the place Gee's Bend, Alabama, we would be doing what is quite a familiar form of colonial violence, taking out the style from the place and the history and the people with which that style has been made. So my argument, my attempt to define style is really that style is a materialization of the deep networks of culture and history within which a creative practice is embedded. And this is something that when we're thinking about computational systems, we have to take seriously, the idea that there are deep networks of culture and history in which creative practice happens. So Lopez, I think, takes the time to elaborate a marvelously detailed catalog of technical practices, where they came from, why they're used, and so on. And yet, at least in their paper, I think Basman and Tchernavskij don't provide us with a similar effort to ground their arguments in the lives of real communities. They continue to see the issue primarily through the lens of technique. And I'd extend this argument to the Salon as a whole, that ultimately we talk about freedoms, we talk about agency, we talk about users, but rarely do we ground our programs and our thinking around programming systems in specific communities, their histories, and their practices. This brings us back to this ideology of constant generalization, abstraction, and so on. So basically, I'd like to call for the question that we should be asking ourselves every time we do our work, every day we do our work creating programming systems, is how do we imagine a different kind of future for computation? One which still grounds our systems, our programming languages, and our abstractions within the history, place, and practices of specific communities. And how do we acknowledge the importance of technique, of abstraction, of generalization, without losing grasp of what's surplus to it, what gets lost when we think about our environment simply instrumentally. I'm just about finished. I wanted to make one quick nod to the question of metaphors. And I think Philip's introduction really brought this to light. So in the paper, Antranig and Philip talk about use this metaphor of imprisonment and being interested in communities having the power to effectively and economically own their software. And to borrow Antranig's slide from his response the other day, I asked whose community and what tools? Again, back to this question of specificity of history and practice. We can't forget the prisons too have a material history and context, especially for those of us in North America. These are places that do real physical violence to First Nations people, certainly here in Canada, and Black communities in the US. And they are biased towards being deployed as an instrument against those communities. So we should think that metaphors have the power to do real violence too. Yet in some sense in the paper, we're being asked to treat this imprisonment metaphor as if it were simply stylistic, as if it were in the computational sense of style, just a rhetorical technique. So I asked the question, who specifically is imprisoned by programming styles? Who holds the social power to put them there? And how do we break down the walls of this prison? Lastly, I'll leave with a quote from Hilary Mantel's A Greater Place of Safety, in which I think quite ironically, Robespierre says, metaphors are good. I like metaphors. Metaphors don't kill people. But of course, many of the people, the characters in the novel and in the French Revolution itself were men of letters, journalists, writers, etc. And the relationship between written and metaphorical violence and actualized violence is really the key theme of this book. So our metaphors and our styles do have a real value. And with that, I think I will cede the floor to questions.
Thank you very much, Colin, Philip, and Antranig. I think it's somewhat telling for this discussion, but when I originally pointed out the quote, metaphors are good, I like metaphors, metaphors don't kill people, to Antranig, he replied, really? Are you sure? So I think that shows the level at which this is on point for the inherent complexity of this discussion. So if anybody has a question, I see Joel has his hand raised. Go ahead, please, Joel.
Thank you.
Joel, you're
Joel,
very
I'm sorry,
quiet.
you're inaudible. Please, could you try again? Okay, Joel, I suggest you write your question in the Zoom chat, and whilst you're doing that, we'll go over to Jonathan.
Okay, thank you. Very interesting conversation. So your intrusive composition operator comes into difficulty with names, right? This is one of your problems, right? Is that the alignment or registration of these programs depends on the names they happen to have internally. Whereas if these programs were not text strings, but actual data structures with internal unique IDs, one could have the idea of a pointer, a stable pointer into a program at which to intrude your modifications. However, that requires a lot of infrastructure, obviously, unlike text. So how do you feel about this trade-off? Are you happy with names, or are names need to be abandoned?
More than being happy with names, I think we feel names are indispensable. I mean, the problem with the pointers, the stable pointers to data, is that they are unutterable, they are unexternalizable. So you cannot hand the pointer, your pointer, to me and have me interpret it without all of your machinery. So the whole point of externalized composition is that I can hand you the raw materials and the operator, and you can do it yourself. That is, you don't need me and my infrastructure to do the composition for you. So that's sort of my first pass as an answer to that.
Okay.
And I would add to that slightly by saying that we particularly see the difference between these when we go beyond trivial examples like the one we gave in the words with Z solution. Once we need to reference things deeply, then things like selector dialects and path expressions are sort of useful, are particularly useful deployments of names, and also reflect the ways in which we often draw an analogy to CSS as being a very effective structure for communities of authors sharing names, because there can be some agreement over time on what class labels to use on aspects of a design, and through that different authors, those who style a document, those who develop the HTML template, etc., can collaborate on in a shared space.
So Joel's
Thanks.
now, sorry, thanks, Jonathan. Joel has posted his question that on one slide you say that imprisonment is not convivial or similar. This suffers from the form of argument, thing that is considered to be bad is bad. What are the two things that you're actually connecting by this metaphor? So decompose imprisonment into something most of us take as normal and acceptable, e.g. as an abstraction. The layers and circles of hell from processor design above, connection only at system boundaries.
Yes, so the thing we're arguing is bad is the inability to work on programs in the open. So when we talk about how our composition operator works, the point is that it can be made to work without relying on the facilities of the closed world in which the expressions are executing. And so that is the thing we're saying is not convivial. Hopefully that connects the thing, that the value judgments in a non-trivial way.
And Michael, I think, has his hand up.
Hi. Can everybody hear me?
Yep.
Yeah, okay, good. So can you give, so you give this sort of little configuration language, but then you critique it. Can you give an example of what you imagine a fully worked out version of external program composition would be like for the end user, and how it is distinct from connecting programs at their edges? I find myself having trouble actually envisioning what this would be like as a programmer, as a user, not the programmer. Yeah, that's my question.
Yeah. Philip, would you like to talk about malleability a bit and some of its?
Sure. So yeah, ultimately, there's different expressions of this based on what domain you're interacting with a program in. But I particularly am very so I come from the discipline of human-computer interaction, I'm particularly interested in interface design, the construction of usable and appropriable interfaces. And so the sort of canonical example that I often come up with is that you might be using two different applications or things that look like applications in the sense that they're windows that contain, graphically represented tools and some kind of area in which you work on data expressed in a particular reified form. And maybe you have experiences like I often do, where I'm working with several illustration tools at once. And I find that one window has a particular tool that I want to use in the other window. And only for that, and only because of that, I am going through this whole indirection of moving my work from one application to the other. Whereas the end user example that we'd like to bring into reality is that, if you say have a color manipulation instrument in one window, you could literally just drag it from one window to another. And then all the work of establishing the bindings and relationships that allow that color picker to function in the context of the application which we're changing just happens in the background. And so there's a great deal of subtlety happening there that I don't think can just be boiled down to sort of this widget uses the API of the application that we're adding it to. So we have more illustrations of this in past papers that I can link to in the chat.
So I'm going to take the liberty of the host of this to try and direct the conversation to bring Colin a little back more into it. So I wonder if it felt to me, Colin, like some of what you're asking for is a regrounding of the history of programs into something that a large part of the intellectual discipline of computer science is attempting to abstract away. So it's a kind of a history of the ahistorical to some extent. Other places where, other times that you're aware of, that we could go and read as a community to understand techniques and practices for ways of even beginning to think about how to make a change that substantial?
Well, yeah, I mean, I think what I'm advocating for is if we're interested in cataloging histories of programming, that I'm interested in including the social history of computation, which means stories of how systems are used, don't work, do work in various cases. So I mean, I think there's the sort of ethnographic streak to the Scandinavian participatory design world that Philip mentioned the other day, things like artifact ecologies, where you can see papers Susanne Bodker's written where she spends time in real communities, not just users writ large, but how does a food co-op in Denmark manage their website, handle online orders, other things like that, and starts to trace the barriers that aren't simply technical in nature, but also about knowledge and the power that having technical skills brings. So, the classic example of the programmer who designed and implemented the website in WordPress, who then vanishes from the community, at which point everyone's figuring out how to keep the WordPress site running and these kinds of things. I think there's also an aspect of a critique to this, I think, largely performative sense of objectivity. I don't believe that what we're doing is science, that politics are a separate realm. I think implicit politics are, in fact, the most explicit form of politics. So if you say, oh, I'm not political, I'm just making a programming language, you're, in fact, I think, articulating a position of the most vehement commitment to the status quo, other things like that. So, we could look to some of the science and technology studies work that, puts this science in a position that's less, I don't want to say in opposition, but perhaps ignorant of the cultural forces that help to construct them. I don't know if that answers your question.
Yeah, so it sounds like kind of the places like the alternative narratives of the history of computing, like, yeah, interesting. So I'm afraid that's all we have time for, and that I'm conscious that we have another talk coming up right now. So I would encourage everybody to virtually clap to thank the speakers once again. So thanks very much, everybody. I'm going to stop the recording now and restart it again and hand over to Colin, who I think you're chairing the